Alright, so in this problem, I have 2 to the power of 100 minus 2 to the power of 99. Now, first off, I'm going to replace 100 here with 99 plus 1. So now I have 2 to the power of 99 plus 1 minus 2 to the power of 99. Now, if I have something in the form a to the power of m plus n, this is simply equal to a to the power of m times a to the power of n. So in this case, a to the power of m plus n, well, we have 2 to the power of 99 plus 1. We think of a as 2, m as 99, and n as 1. So now I'm going to put this in the form a to the power of m times a to the power of n. So a is 2, so I have 2 to the power of 99 times a to the power of n, so 2 to the power of 1. Now I have this minus 2 to the power of 99. Now from here, as you can see, both terms have 2 to the power of 99 in them, so I'm going to simply factor out 2 to the power of 99. So now I have 2 to the power of 99 times, well, 2 to the power of 99 times 2 to the power of 1 divided by 2 to the power of 99, well, all that's going to be left is 2 to the power of 1, and negative 2 to the power of 99 divided by 2 to the power of 99 is negative 1. So now this is equal to 2 to the power of 99 times 2 to the power of 1 is 2, 2 minus 1 is 1. And 2 to the power of 99 times 1 is simply 2 to the power of 99. Now I actually have a second method of solving this problem. So my problem was 2 to the power of 100 minus 2 to the power of 99. However, this time, instead of changing 100 to 99 plus 1, I'm going to change 99 here to 100 minus 1. So now I have 2 to the power of 100 minus 2 to the power of 100 minus 1. Now I can rewrite this as 2 to the power of 100 minus 2 to the power of 100 plus negative 1. And remember, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 100 plus negative 1, that's going to equal 2 to the power of 100 times 2 to the power of negative 1. Now if I factor out 2 to the power of 100 from here, 2 to the power of 100 times 1 minus 2 to the power of negative 1. 2 to the power of negative 1, that's equal to 1 half, so I have 2 to the power of 100 times 1 minus 1 half. 1 minus 1 half, that's simply 1 half, so I have 2 to the power of 100 times 1 half, and 1 half is simply 2 to the power of negative 1. So now I have 2 to the power of 100 times 2 to the power of negative 1. And remember, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of 100 times 2 to the power of negative 1 is equal to 2 to the power of 100 plus negative 1, which is equal to 2 to the power of 99. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. Alright, so I have 8 to the power of x plus 8 to the power of x plus 8 to the power of x plus 8 to the power of x is equal to 8. So what I'm first going to do is I'm going to factor out 8 to the power of x from my left-hand side. So now I have 8 to the power of x times, now 8 to the power of x divided by 8 to the power of x is 1. So I have 8 to the power of x times 1 plus 1 plus 1 plus 1. Now this is equal to 8. Now 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 1 is 4. So I have 8 to the power of x times 4 is equal to 8. Now, if I divide both sides by 4, these two cancel out, and I'll be left with 8 to the power of x is equal to 8 divided by 4, which is 2. And 8 here, this is the same thing as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x is equal to 2. And 2 to the power of 3 to the power of x, that's the same thing as 2 to the power of 3x is equal to 2. And now if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2 is the same thing as 2 to the power of 1, so 3x is equal to 1. Now to solve this, all I have to do is divide both sides by 3, these two cancel out, and now I'll be left with x is equal to 1 over 3. So this is my answer. So now if I plug in, now to check, first start with a to the power of x plus a to the power of x plus a to the power of x plus a to the power of x is equal to 8. So I know the value of x is 1/3, but before that, I'm actually going to change 8 to 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of 3 to the power of x plus 2 to the power of 3 to the power of x plus 2 to the power of 3 to the power of x is equal to 8. Now x is 1/3, so now I have 2 to the power of 3 to the power of 1/3 plus 2 to the power of 3 to the power of 1/3 plus 2 to the power of 3 to the power of 1/3 plus 2 to the power of 3 to the power of 1/3 is equal to 8. Now 3 and 1/3 are going to cancel out, so now I'll be just simply be left with 2 plus 2 plus 2 plus 2 is equal to 8, and 2 plus 2 plus 2 plus 2 is 8, so I have 8 is equal to 8, and because this is right, my solution is right. Alright, so in this problem, I have x to the power of 4 minus 9 is equal to 0. So to solve this, I'm going to first replace x to the power of 4 with x to the power of 2 times 2. So I simply substituted in 2 times 2 for 4. So now I have x to the power of 2 times 2 minus 9 is equal to 0. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can rewrite that as x to the power of 2 to the power of 2. Now this minus 9 is equal to 0. Now 9, this is the same thing as 3 to the power of 2. So now I have x to the power of 2 to the power of 2 minus 3 to the power of 2 is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. In this case, a is equal to x to the power of 2 and b is equal to 3. So now I have x to the power of 2 plus 3 times x to the power of 2 minus 3. And this is equal to 0. Now I can split this into two equations. I have x to the power of 2 plus 3 is equal to 0, and I have x to the power of 2 minus 3 is equal to 0. So for x to the power of 2 plus 3 equals 0, I can simply subtract 3 on both sides, and I'll be left with x to the power of 2 equals negative 3. Now if I take the square root on both sides, square root of x squared is x, and the square root of negative 3 is the same thing as the square root of 3 times the square root of negative 1. And the square root of negative 1 is equal to I. So now I have x is equal to square root of 3i. This is positive or negative. So those are two solutions. Now for x squared minus 3 equals 0, I can add 3 on both sides, and I have x squared is equal to positive 3. Now if I take the square root on both sides, square root of x squared is x, and I have positive or negative square root of 3. So these are two more solutions. So now, my four solutions are x is equal to positive square root of 3i, x is equal to negative square root of 3i, x is equal to square root of 3, and x is equal to negative square root of 3. So these are my four solutions to this problem. Alright, so in this video, I'm going to be solving the equation x to the power of x to the power of 6 is equal to 144. So, to solve this, what I'm first going to do is take the power of 6 on both sides. So I get x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And m and n, I can switch these two. So this is equal to a to the power of n times m. Now, if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m, this should equal a to the power of n to the power of m. Meaning, a to the power of m to the power of n is equal to a to the power of n to the power of m. So now that we know this, we can think of x to the power of 6 as m and 6 as n, and using this property, I'm going to switch these two places. So now I have x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. So now from here, 144 is the same thing as 12 squared. So I get x to the power of 6 to the power of x to the power of 6 is equal to 12 squared to the power of 6. And remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 12 to the power of 2 to the power of 6 is going to equal 12 to the power of 2 times 6, which is 12 to the power of 12. And now, my final step is that if I have something in the form a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, x to the power of 6 is equal to 12. So now we want to get rid of this power of 6, so I'm going to take the sixth root on both sides. So I get the sixth root of x to the power of 6 is equal to the sixth root of 12. Now the sixth root of x to the power of 6 is simply just x. So I get x is equal to the sixth root of 12, which is the same thing as 12 to the power of 1 over 6. So either of these two work. So this is my answer to this problem.